questions 1 through 4 on the 2017 Grade 12 Euclid Math Contest. There is one pair AB of positive integers for which 5a plus 3b is 19. What are the values of a and b? 5a plus 3b is equal to 19. So we have to find integer solutions. So we just play around with this. Let's say a and b, if we put into a tabular format, some of you can do this in your head, but let's just say it's 1. That would mean that 3b would be equal to 14, and that's not going to give me an integer solution. All right, no problem. Let's keep going. Let's try 2 for a. That's going to be 3b is going to be 19 minus 10, which is 9, and that does indeed give me an integer solution. So that means that AB is 2, 3. So that takes care of part A. How many positive integers n satisfy 5 is less than 2 to the power of n is less than 2 to the power of 17? So basically this 2 to the power of n has to be in between those two numbers. So what are the powers of n? Powers of 2, I should say. 2 to the power of 1, 2 to the power of 2, and so on, right? So what we basically have to do is figure out how many of these fit into that range. And I think I'll go up to 2 to the power of 11. Well, this is 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and 2048. So in this range, obviously, it's these guys from there to there, because everything else is outside of that range. So it looks like 1, 2, 3, 4, 5, 6, 7, 8. 8 values, in particular 8 positive integers that satisfy that inequality, 8 values of n. So there we go. Part C. Jimmy bought 600 euros at a rate of 1 euro equals $1.50. He then converted his 600 euros back into dollars at a rate of $1 equals 0.5 euros. How many fewer dollars did Jimmy have after these two transactions than he had before these two transactions? 1 EU is equal to $1.50. So that means 1 over 1.5 is equal to 600 over D1. So D1 is equal to 900. That is the amount of dollars that he had in the beginning. And then later, we have a scenario where 0.5 euros over $1 is going to be the exchange rate when he tries to convert it back. And that is going to be 600 over, I guess, D2, which is what we're trying to find. So that means 0.5 D2 is equal to 600. So D2 is equal to 800. So in the beginning he had 900. After the exchanges he had 800. So obviously he has $100 less. When they say how many fewer dollars did Jimmy have after these two transactions than he had before, the answer is he had $100 fewer after the two transactions. What are the values of x for which x does not equal 0 or 1 for that expression? So that expression is 5 over x times x minus 1 is equal to 1 over x plus 1 over x minus 1. Well, get a common denominator, multiply both sides by the necessary term, and that gives me x minus 1 plus x over x times x minus 1. The denominators are the same, so that means the numerators must be equal. So that means 2x minus 1 is equal to 5, 2x is 6, and therefore x is 3. So that's the only value. They say values, which irritates me when they say plural, because that makes you think that there's more than one. But in this case, there isn't. There's only one. And as always, I encourage you to substitute that value of x back into the original equation to verify that left side does indeed equal the right side. In a magic square, the numbers in each row, column, and diagonal have the same sum. In the magic square shown, what are the values of A, B, and C? Well, that's the only column that's complete, so let's work with that. 20 plus 4 minus 12, that is 12. So it looks like 12 is the main number here. The sums are all going to be equal to 12. So now we just proceed. So if I look at this row, 0 plus 20 plus A is equal to 12. So that means A is equal to minus 8. So we got one value. Keep going. I guess I can use this diagonal to figure out B. 0 plus 4 plus B will be 12. So that means B is equal to 8. All right, great. I got another one. I guess where do I go to find C here? Well, C is here. I think I will need to know what's this guy, so I'll just call that X. So A plus X plus B is equal to 12. Well, A is negative 8, and B is positive 8. So that looks like X is equal to 12. So now I can concentrate on that row. C plus 4 plus X, which is 12, is equal to 12. Therefore, C is equal to negative 4. So A is equal to negative 8, B is equal to positive 8, and C is equal to negative 4. So there we go. For what positive integer is 100 squared minus n squared equal to 9559? All right, well, 100 squared is 10000 minus 9559 is equal to n squared. And that is 441. And then if we take the square root, we get n equal to 21. And we only want the positive one, so we don't have to worry about negative 21. Part 2. Determine one pair AB of positive integers for which A is greater than 1 and B is greater than 1, and AB is equal to 9559. A times B is equal to 9559. Now you can play around with this, get your calculator. Let's see, does it divide by 2? No. 3? No. 4? And that would take a long time. So what you do is you use part A. 100 squared minus n squared is 9559. So this part factors, as I'm sure you can. 100 minus n, 100 plus n. 9559. And n, we just figured out. So this is going to be 100 minus 21, 100 plus 21. 9559. And when you do that math, it is 79 and 121. So that means that AB, that pair, is 79 and 121. And there you go. In the diagram, triangle ABC is right-angled at B, and triangle ACD is right-angled at A. Also, AB is 3, BC is 4, CD is 13. What is the area of the quadrilateral ABCD? Well, if you're in grade 12, I'm certain you know that's a 3, 4, 5 triangle. You don't even have to do Pythagoras. If you are in grade 12, you definitely know that. And then most of you probably can do this Pythagorean relationship in your head, but just in case you can't, we'll just put it on the screen. 5 squared plus AD squared is equal to 13 squared. So that means AD squared is equal to 169 minus 25, and that means AD squared would be 144, so AD is 12. And there we go. Okay, so now I can easily figure out the area. It's just two triangles. So ABCD would be 1/2 base times height for this triangle, which is 3 times 4, and then 1/2 base times height for that triangle, which would be 1/2 12 times 5. So let's see, what's that? 6 plus 6 times 5, 30, and therefore that is 36. 36 is the area of the quadrilateral ABCD. Three identical rectangles are arranged as shown, so that RS lies on TX. The perimeter of each of the three rectangles is 21. What is the perimeter of the whole shape? Well, let's give some values here. Let's call this x. Let's call this y, 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 x, x. Now, this part here, I have to break up. So I'll just call that part a. And then this part here will be x minus a. And then this part here is going to be, since this is all x, this part has to be, therefore, a. And then this part is going to be x minus a. All right. So the perimeter of this whole shape looks like 1, 2, 3x. And then 1, 2, 3, 4y. And then this a, and then this x minus a. Okay, so that gives me, the a's cancel, 4x plus 4y. Great. Now, they told me the perimeter of each of those rectangles is 21, so that means 21 is equal to 2x plus 2y. Each of those triangles, rectangles, has a perimeter of 21. So that means this, which is essentially just 2 times 2x plus 2y, is just 2 times 21, which is 42. So there we go. That's the perimeter of the whole shape. One of the faces of a rectangular prism has an area of 27 centimeters cubed. Another face has an area of 32 centimeters cubed. If the volume of the prism is 144 cm cubed, determine the surface area of the prism in centimeters squared. All right, so we've got some prism, and I'll just draw a very rough sketch. Doesn't need to be fancy. And I'll label them X, Y, and Z. Those are the sides. So they've told me that one face has an area of 32. So I'll say maybe this is 32. So y times z is 32. Another face has an area of 27. Okay. So I'll say that that's going to be perhaps the bottom of that shape is 27. So that means x times y is 27. And then the only other face that we didn't talk about would be the x times z face. So xz, that one we don't know yet. Okay, so we also are told that the volume is 144. So xyz is 144. So let's substitute these two guys. So x times 32 is equal to 144, right? Because yz is 32. And therefore x is equal to 144 divided by 32, which is 4.5. And in a very similar way, if xyz is 144, we can substitute xy as 27. So 27z is 144, and therefore z will be 144 divided by 27, which is 5.3 repeat. So now we can figure out xz. It's going to be 4.5 times 5.3 repeat. And that gives you a very nice number, 24. So what did they want us to figure out? Surface area, SA. Surface area is going to be 2 times xz plus 2 times xy plus 2 times yz. So that's 2 times 24 plus 2 times 27 plus 2 times 32. And when you do that math, you get 48 plus 54 plus 64, and that is equal to 166, is the surface area of that prism. The equations represent the same parabola. What are the values of a, h, and k? All right, so let's work with this now. We are given y is equal to a times x minus 2 times x plus 4. And then we are given y is equal to 2x minus h squared plus k. They're saying that these are the same. All right, well, if they're the same, I guess I have to compare them. let's draw a very rough sketch using this guy right here. When this is the x-axis, obviously, and that is the y-axis. So when x is 2 and when x is minus 4, those are the roots, right? And I have no idea if it opens up or if it opens down, but let's just say it opens down like that. So that's a parabola. And the vertex will be the point in the middle. So 2 and minus 4, that's a distance of 6. So in the middle is going to be 3. So 3 is going to put me at minus 1. So this vertex is minus 1. And the value of y, the y coordinate, that I don't know. But I can substitute negative 1 into this equation for x. So that would mean y is equal to a times negative 1 minus 2 is minus 3. And then negative 1 plus 4 is 3. So y is equal to minus 9a. Minus 9a. Okay, that's pretty decent progress. From this, that form is interesting because it tells me the hk is the vertex. That's why they put it in that form. That's what that form basically is. Well, we can pretty much deduce from this that the vertex was negative 1 minus 9a. So that tells me that h is negative 1. So that's the first value that I get. All right, so now let's move forward, try to get another value. Well, from this graph and this equation, we know that the graph crosses the x-axis at 2 at negative 4. Those are, of course, the x-intercepts. So we can sub one of those into there. Let's put in the one that's 2, 0. This guy right here. So if I put 2, 0 into y is equal to 2x minus h squared plus k, let's see what happens. So y is 0, x is 2 minus h, but h I just got was negative 1, and then plus k. This will allow me to solve for k. So this is going to be 3 squared, 9 times 2, 18 plus k, so k is negative 18. All right, great. So I've got the 2. And I guess what's the other one? A. Okay, well, A is the same as that, right? In terms of like comparison, k is equal to minus 9a. Well, k is negative 18. That's minus 9a, so a must be 2. So they wanted me to find the values of a, h, and k. And I did. Those values are 2, negative 1, and negative 18 respectively. And I encourage you, as always, to sub these values back into here and here to verify that those are indeed equal to each other. In an arithmetic sequence with 5 terms, the sum of the squares of the first 3 terms equals the sum of the squares of the last 2 terms. If the first term is 5, determine all possible values of the 5th term. We have 5 terms, and an arithmetic sequence is of the form a plus d, a plus 2d, a plus 3d, a plus 4d, and so on, right? You guys know about that. So the question is saying the sum of the squares of the first 3 terms, so that's going to be a squared plus a plus d squared plus a plus 2d squared. That equals the sum of the squares of the last 2 terms. So a plus 3d squared plus a plus 4d squared. Okay, that's the setup. But they gave us another very important clue that the first term is 5. So this a equals 5. So that's very helpful. Let's substitute a equals 5, and off we go. Okay, so at this point we have to do some expansion. I don't think it'll be too bad. 25 plus 25 plus 10d plus d squared plus 25 plus 20d plus 4d squared. And then that's going to be 25 plus 30d plus 9d squared plus 25 plus 40d plus 16d squared. Put everything on one side to collect like terms, and when you do, you get 20d squared plus 40d minus 25. And then divide through by 5. That will give me 4d squared plus 8d minus 5. I think this factors. Let's see here. 2d, 5, 1, positive, negative. So that means d is either equal to minus 5 over 2 or it's equal to 1/2. So they want me to find the values of the fifth term. Okay, well, the fifth term is this guy right here, a plus 4d. So a plus 4d, if I use the value of minus 5 over 2, it's going to be 5 plus 4 times minus 5 over 2. And that is equal to minus 5. If I use a half, a is 5 plus 4 times a half, and that is 7. So there we go. These are my two possible values for the fifth term.